Absolutely. So I'm going to queue up this talk from Mark Needham. And yeah, so enjoy that, and I will see you on the flip side of that.
Hello, Pyjamas Conf. My name is Mark Needham. I'm a developer advocate at Startree, and in this presentation, we're going to learn about the real-time analytics stack. Let's start with the definition. So this is the definition of real-time analytics that Gartner gives. So it's the discipline that applies logic and maths to data to provide insights for making better decisions quickly. Let's see if we can figure out a definition that's a bit more practical. So we all know about events. So events are things that can happen. So it could be I searched for a hamburger that I want to buy. I visited a website. It's a metric from an IoT sensor. And these events happen, and we want to try and learn something from them. Like, what insight can we gain from knowing that an event happened? And then once we've got that insight, what action can we take as a result of figuring out that insight? And so that's what this whole talk is about. It's like, can we go from events to potentially some action? And the value of data decreases over time. So you can see here on the y-axis we've got the value, and then on the x-axis we've got the time. And you can see over time it reduces in value. And the bit that we're interested in for this talk is the bit on that left-hand side, the real-time bit. And if we can do something with that data, then we can actually build some really cool data products. So who's interested in this data? So it could be analysts who are running inside a company. It could be the managers of those analysts who are interested in knowing what's going on with the business. And it can actually be, we could loop that data all the way back to our users and build some cool data products for them. Let's just have a look at some examples of real-time analytics. So LinkedIn is a good one. So I'm sure most of you will have seen the Who Viewed Your Profile page. And this is a real-time, up-to-date view of how many people have viewed it. If you have the free version like me, you'll see a subset of those people. And then if you pay for it, I think you can see everybody who's seen it. And so this is a user-facing analytics application that is operating for 700 million users at sort of 10,000 queries per second. And then they have other ones as well. So you have the news feed, and the goal there is the action they want you to take is interact with this stuff. So they want to show you stuff that you're going to interact with. So they kind of keep a track, like what have you been interacting with in the past? What have you been liking? What have you been commenting on? And they're going to try and show you more stuff like that to try and get you engaged with the platform. And then the final one is they've got an internal application for recruiters called the talent pool report, where recruiters can kind of see across lots of different dimensions, like what is going on, like in real time with the job market, like what locations are people looking for jobs in, what types of jobs are available. And then we'll just do one more. So Uber Eats is another cool example. So this is the restaurant manager dashboard. So if a restaurant is operating on Uber Eats, they'll get a dashboard like this, so they can see hey, I've got these. This is my revenue that I'm making, and it compares it to the previous period. I can see the top selling items. I can see any feedback that I've got on the menu. And then most interestingly, in terms of action based metrics, we've got the missed orders and the incomplete orders. And so if we saw that those were happening, perhaps we could actually go and do something about it. Maybe we're going to get a coupon over to those people, or maybe we're going to call them up and say, hey, look, I know we've missed this order. We're going to sort it out. And so what I want to do in this first half of this talk is tell you what tools do we need to build these types of applications so that we can all be like LinkedIn or be like Uber Eats. And so I want to give you a map of the tools that that are available in this space. So this is a diagram showing all the different tools that we use as part of the real-time analytics stack. So we've got the event producers. They are moving data into the streaming platform. We've potentially got a stream processor operating on the data in the streaming platform. We've then got a serving layer sitting there afterwards. And then finally, we've got the front end that is serving the data to the users. And we're going to go through these one by one. So we'll start with the event producers. So where do events come from? So the first place is they could come from our existing infrastructure, so existing OLTP databases. We could use the change data capture pattern to capture the changes that are being made to our OLTP databases in MySQL or Postgres. We're using tools like Debezium to stream those messages into the streaming platform. And then another one could be event trackers. So we're browsing on a website and they're capturing what are we doing on the website? What pages have we visited? Where have we looked at? Like getting those kind of views on, hey, look, a lot of users are looking at this part of the screen, like that type of data. Like all that is events that event trackers might be streaming into a streaming platform. And then finally, it might just be a language SDK client. So perhaps you're capturing your own events and putting them into a streaming platform. So there's lots of different ways that we can get those events. Once we've got those events, we're then into the streaming platform itself. And the streaming platform ingests events from those sources in a scalable way and stores them durably. And it'll often be storing them in a topic. So like different type of events go in different topics. And typically it'll be based on some sort of distributed log file. Events are appended to the end, and then we can partition them, the log, across multiple servers so that we have durability and scalability. And so here's an example of what a log might look like for a single partition in a Kafka topic. So we've got lots of records. They're going from older to newer. In theory, we have an infinite log, but in practice, we're probably truncating that at some period in time. And the technology choices in this area, so there are lots of them, right? Kafka's probably the most well known. We've got Red Panda, we've got Ably, we've got Google PubSub. Pulsar is a newer one. There's lots of different tools that you can choose from that are being used to store these events. Right, next up, stream processors. So there are lots of energy around this one at the moment. So what is a stream processor doing? So generally the events are coming in to our event streaming platform, and then the stream processor might be operating on those events. And it could be taking data, most likely it's taking data from an input topic and then putting it into an output one. And it could be doing some joins while it's doing that. Perhaps it's creating a materialized view. It could be doing streaming ETL. There's lots of different things that it could be doing. And then there are kind of like, it could be passing it on to the serving layer, but there are actually sort of three types of things that can happen with the data. First one is maybe we're just building a streaming analytics application. So we could just build stuff on top of the stream processor itself. We don't necessarily have to pass it to the serving layer, although in this talk we are obviously going to be using the serving layer. And we could be doing stateful aggregations, window operations, materializing a stream and then feeding it onto somewhere else. We could be building an event-driven microservice. So perhaps we've got like an event-by-event processing app sitting on top of this. And then finally, we could be using it for streaming ETL. So we could be doing some joins, some filtering, some routing. Maybe we're doing some repartitioning of the data and then passing it on to someone else. And there are, again, lots of tools around here. So Kafka Streams, I guess, was one of the early ones, but there's now lots of different ones. There's Materialize, Quix, Bytewax, Faust, Memgraph is a graph-specific one, and there are lots of others as well. And then now we move on to the serving layer. So this is where the data is going to live before we serve it to our front-end application. And so this will be connected to the event streaming platform, and then it's possible that a stream processor might be operating on the data in the event streaming platform before it makes its way to the serving layer. Generally, there are some desired properties for the typically OLAP databases that are living in here, but there are other databases as well. We want the data to be fresh, so we need to get it from the streaming platform to the users as quickly as possible. So we need to be able to get it in there fast. And then once we're querying, we want OLTP type query speeds on this OLAP type data. And then we need to be able to operate at high throughput. So potentially lots of users doing queries, or maybe lots of dashboards doing lots of queries for each refresh of the dashboard. And then we generally want some sort of way to query the data that's in this database. So like doing some joins, some aggregations, and filtering on these large data sets. And the technology choices under the serving layer generally fall into two types. So we've got the key value stores and NoSQL databases. So that's your Redis, your Elasticsearch, your Mongos. And then over on the right hand side, we've got more recent additions. So these are kind of databases that are optimized for doing real-time querying. So we've got Apache Pinot, we've got Druid, ClickHouse, and Rockset. And now finally, we look at the front end. So this is the tooling which is going to be used by our users. And they could be internal users, they could be external. Like we don't differentiate between those. And it could be, if we have like some in-house expertise, perhaps we're going to build something ourselves. So I would, out of these tools, these are React, Vue, and Angular, and there are lots more. I've just picked a few to start with. I would lean towards React, but I appreciate there are people who like the other ones better. In the middle, we could be using a low-code framework. So perhaps we're using something like Dash or Streamlit, and then, or perhaps even we'll use a data visualization tool, so even less code. So Redash, Superset, or Metabase would be some tools in that area. Now we're going to have a look at a demo. So how can we actually put all these tools together? And we're going to be using the All About That Dough Pizza Shop demo app that I've been working on. So if you want to find that to follow along, you can get it from this QR code or this URL. And now we're going to move over to have a look at the demo. Okay, so All About That Dough have an existing architecture which we can see now. So they're getting orders. We've got an orders simulator, which is simulating like the people sending orders. We're putting those imaginary orders into the orders stream. And then we've also got some data in MySQL. So we've got a bunch of products and some users as well. Let's just have a quick look at the data that we've got before we do any real-time analytics. So we're going to connect to our MySQL container. And we'll write in our password, and then we'll just write a quick query against the pizzashop.users table. As we can see there, we get some users coming back. So I think we've got about 1,000 users in there, but those are just a few of them. And now if we do the same thing with the products, we can write a query against that table, and you can see there we go. We've got a bunch of products that we're going to be working with as well. If we now exit MySQL and let's now query our Kafka instance. So we're going to be doing this using the kcat CLI tool. So this is a tool for querying Kafka streams. And we're going to query it, get it to query, pass in the name, the location of the broker, the name of the topic, in this case orders, and we'll just tell it, give us all the messages. So you can see those now come flying through. There's loads and loads of orders coming through. So let's run that for a few seconds, and now we'll stop. So there we go. So that's where we are. That's where we're at. Now we're going to look at the new architecture that they want to evolve to. So we're going to, first of all, put the orders stream into Apache Pinot, and then we'll have a Streamlit app writing queries against Pinot and building like a dashboard around all the data. And so that will give us like the overview of the orders. And then the extension of that is that we're going to combine the orders with products. So we're going to write the products from MySQL into a product stream, which we'll be treating as a table in Kafka, or K-table in Kafka streams. And then we'll join that together with the orders, having flattened the order items out into an enriched order item stream, and we'll also load that into Pinot. So we're going to have two sets of data in Pinot. So that's what we're going to try and do. So let's have a look at that. So first of all, we need to get the orders stream into Pinot. So let's get into VS Code, and we'll look at how we would go about creating a table in Pinot. So each table in Pinot comes with a schema. So let's open our schema file. And so what we can see here is we've got the description of the different fields that are going to be in our table. So we've got a bunch of dimensions, and Pinot uses like kind of the terminology of a data warehouse. We've got dimension fields, we've got ID, user ID, status, and then we've got JSON string for items. And then we've got metrics. So these are generally numeric values. So we've got products ordered, we've got total quantity, we've got price. And then finally, we've got a timestamp. So every time you're loading data in from a stream, you need to have a timestamp associated with it. Now let's have a look at the table config that goes along with this schema. As we can see here, we've got to have the same name. So the name of the table and the name of the schema need to be the same. We're specifying that it's a real-time table. So what that means is that data is going to be coming in from some sort of streaming platform. You can also have an offline table, and in that case, you'd be batch loading the data, and it won't expect that streaming config to be there. And you can actually have an offline and real-time table together, like with the same name, and query both the sets of data together if you want to. Now let's just scroll down a little bit. And so now we can see the streaming config. So in this case, Kafka, we've got to specify where the broker is. We need to specify the name of the topic. So in this case, orders. And then we're saying the type of ingestion is going to be low level. And what that means is that if you have multiple partitions, it's going to spin up multiple consumers on the Pinot side to get the data in. If we scroll down a little bit more, we can see that we've got the transformation functions. And so what these are for is if we've just got some small changes that we want to do to the data that's coming in from the stream that doesn't maybe warrant introducing a stream processor, we can just do those inside Pinot itself. And so in this case, the timestamp is not in the right format for what we need. We need like a very specific format. And so we're going to use this from date time function to get it into epoch milliseconds. We're going to do the same. And then we're also going to do pull out the total quantity. So there isn't actually a field called total quantity on our orders events, but it is hidden inside items. So we're going to use a JSON path function. So we're going to do a sum over all the quantities inside those items, and that's going to go into the total quantity field. And then we're going to do a similar thing for products ordered. So again, that field doesn't exist, but we can call the length function on the items and then pass it into a JSON path array, and that will give us all the products that have been ordered. And so now we're going to go to the Pinot UI and have a look at the data that we've ingested. So we're going to go to the query console, and we're going to query the orders table. So let's just write a query that gets back a few of the orders. And so we can see there are a few thousand in there already. So we're doing well so far. So far, so good. Right. So that's the first part of the infrastructure. The next part is we want to be able to join the orders with the products. So let's have a look at how to do that. So first thing is, remember we said we're going to load the products from MySQL into the products stream. So let's just use kcat to check that we've got something in the product stream. So we can run that, and you can see like we've got a bunch of products. It's actually entered the stream because there's not that many. It's only just under 100. Now let's have a look how we're going to join those products with the orders. So let's open Visual Studio Code again, and we're actually looking at we're going to look at part of a Quarkus app that uses Kafka streams to join the streams together. And every Quarkus app needs to have or Quarkus Kafka streams app even needs to have a topology class. We're going to open our topology class, and at the top you can see the name, the topics are defined. So we've got the orders, we've got the products, and then we've got our new one. So that's enriched order items. And then just underneath there's some deserialization and serialization code. And obviously this is obviously a lot more complicated in Java than it would be in Python. So apologies for that. If we then go down a little bit, we can see that we are extracting the order items. So the items are actually inside an array or inside a list, inside the order, and we need to pull those out. So we're going to flat map those out. And we're going to put those into a new stream. And this time it's going to be keyed by product ID. So we need to make sure the key of the streams that we're joining together is the same. Otherwise, it won't be able to join them. So in this case, product ID is the key on this new order items stream. And then we're going to have the key on the products itself is also the product ID. And so if we scroll down a little bit, now we can join it with the products. And so once we've done that, so we join that on that key, we create our new event. And then we're going to put it into the enriched order item stream. And if we now move back to the console, we can use kcat to have a look at one of the items in that enriched order item stream. And so you can see there we've got like a bunch of data. We've got the timestamp, we've got the product is embedded in there with its ID and its name, we've got the order item itself, and then we've got some other metadata as well. Now we want to get that data into Pinot, so we're going to create an enriched order items table. So let's go back to Visual Studio Code, and again we've got a schema, a little bit similar to before. So we've got an order ID, we've got the product, we've got the fields, and we've got some metrics. We've got the price and we've got the quantity. And then if we go over to the table config, very very similar to the orders table config, but we've got the same broker, different topic. And there's not really any transformation functions that are all that interesting. And then now we're going to go over to our Pinot UI. Let's have a look at this new table. So we're going to query that one, order items enriched. Let's refresh it a couple of times. You can see like more and more order items are coming in. So that's cool. It's all working well. The simulator is working well. And how about let's write a new query. So we're going to write a query that finds the product categories, and then we're going to find the top product categories that have orders in the last 5 minutes. So we're going to do a filtering clause there. And if we run that, we can see side orders and vegetarian pizzas are the most popular category of items that people are ordering at the moment. So that's cool. So this is quite a nice UI for doing ad hoc queries, but it's not like great for giving it to an end user if they don't have familiarity with SQL, or they just want to see, like, just show me the chart. Like, I want to see what's going on. I don't want to have to write the query myself. And so that's where Streamlit comes in. So Streamlit is a Python library for building data applications. And so it's often machine learning applications, but I find it's really good for this type of thing as well. And so we can integrate it with pretty much all the other tools in the Python ecosystem. So in our example, we're going to be integrating it with the Plotly charting library and the Pinot Python client. So let's open it up. So let's get that open in our browser. And so what we can see on the top, we can see the orders and the revenue and the average order value over the last 1 minute. And so you can see it's refreshing every 5 seconds. Let's change that. Let's change it to capture things that have happened over the last 10 minutes. So you can see now we've got a much bigger range. And we can even adjust the refresh rates. We could get it down to every second if we wanted to. If we scroll down a little bit, we can see the popular items and the categories. So you can see again that we've got the side orders and the vegetarian pizzas. And if we go right down to the bottom, we've got the stream of all the orders coming in. So this is like all the things that are just happening right now. Let's just conclude it with the demo by having a quick look at the Streamlit code that is building this dashboard. So let's go into our Visual Studio Code again. And you can see we've got at the top, we're connecting to Pinot. So we've got like our connection string. Then if we scroll down a little bit, we've got the auto refresh codes. That's what's like causing it to loop back to the beginning to go again. And then at the bottom, we make a call to the refresh. And then we're doing some aggregation in the middle to filter for the headline numbers. And that's how those top numbers are being populated. And then finally, we're putting them into the what Streamlit calls metrics. And so, yeah, that's the end of the demo. So hopefully you enjoyed that. And now we'll conclude the talk. I'd like to thank you for listening to my talk, or listening and watching to my talk. If you want to find me, this is where I am. So on YouTube, Learn Data with Mark, or Mark H. Needham on Twitter. If you want to learn more about building these type of applications, we've got a bunch of materials at dev.startree.ai. And I am co-authoring a book with Dunith Danushka, who is the creator of the modern streaming stack. So we're writing a book called Building Real-Time Analytics Systems, which will hopefully be ready in early 2023, but it's already on the early access program on Safari if you have access to that. So thank you again, and enjoy the rest of your conference.